Now we're dealing with something called exponential models. So exponential means that you are repeating multiplication. And so the very simplest exponential model there is 2 to the x. When you graph this, it's going to look something like this. Exponential growth, you hear people say things are growing exponentially. It means that it grows faster and faster the more you move along. And the reason is you are timesing by 2 more and more and more as you go along. And so the normal model is going to be a times b to the x. This a is kind of like your start value. If you start with a town with 1,000 people, or if you have a bacteria there where there's 4 cells, or any other situation where you're starting with an initial amount, that's going to be your a. B tells you basically whether you are growing or you are decaying. Growing is when b is greater than 1. So, for example, this is growth because it's larger than 1. And there is this hidden start value of 1, by the way, outside. Anyway, because it's greater than 1, you see this kind of growth going upwards. You're going to see exponential growth like this. If it's decaying, meaning b is less than 1, but still greater than 0, you're going to just see the opposite. It's flipped around, and you're going to see it get closer and closer to 0. It has an asymptote at 0. So, for example, if you had something like 0.9 to the x, this is going to be a downward exponential like this. So now to use it. A town has 5,000 people. It grows 3% annually. Give the model of the population and estimate how many will be in this town for 11 years. Okay, so we think about a times b to the x as our model. And the way that often books will write it is the amount over a time t. So sorry, sometimes it's x, but since I wrote it as a function of t, I'm going to replace this with t. T standing for time. Okay, so the model would be us putting our initial amount, 5,000 people, and then we have to figure out this b here. It should be greater than 1 because it's growing by 3%. So to grow by 3%, you would multiply by 1.03. So this is handy. If you do 1 plus the rate, that will often give you your b. So this will add on 3% every year. Okay, this is our model. If we put in a time, it's going to be based off of, from now, how much we estimate the population will be. So, in the problem, they're asking us to estimate A11. That means we plug 11 in for our time, and putting in my calculator, what I get is 8,551 point something something something, but I'm just going to truncate it. I'm just going to cut it off. A lot of people will just say around 8,500 people, because this is only an estimate, and we can't assume we would be too accurate with this simple model. Now another example. Radioactive decay happens when you have an element that's unstable, and just over time randomly all the atoms start to decay away. So they start to break down and you start to lose your substance. In this case, the radon decays at a rate of 17% a day, and we start with 92 grams. What will be left after 2 weeks? So we need to write our model. The starting amount is going to be 92. Now it's 1 plus the rate will give you your b. In this case, we are decaying at 17%. So we're going to do 1, and we're going to have a negative 0.17 for our b. So 1 take away 0.17 is going to be 0.83. Now, if we plug in any t, that's going to be the number of days, and should give us an estimate of how much should be left over. So, after 2 weeks, that's the same as asking 14 days. Alright, and we plug this into our calculator. We should get around 6.77, so around 6.8 grams. The last really important aspect of exponential models is something called compound interest. When you have compound interest, after 1 year, the bank charges you for a certain amount of interest, and then on the next year, they charge interest not only on what you had originally, but also the interest that you were charged from the year before. So you get interest on interest on interest, and that's why it's called compounded. So, for example, if you have $5,000 invested, let's say that you have a savings account with a 1% rate for 5 years. Now the model is going to be pretty simple. It's going to be very similar. You have a starting amount, 5,000. You have 1%, which is 1 plus 0.01, so really 1.01. And you're going to do this over 5 years. Okay, I get an answer of the total amount now that you would owe is $5,255.05. So they've charged us $255.05 interest for taking out the money for 5 years. Now this is annual. This means that interest is charged once a year. But banks are greedy. There is a special compound interest formula that takes into account where banks actually charge interest at a rate more than just once a year. So let me explain. In the original example we had, over 2 years, well, we would start with 5,000. We would times by 1.01, and then times by 1.01 again, and that would get us the amount after 2 years. Now, in this example, that would mean $5,100.50. But banks, again, they're greedy, so what they do is they think, well, can I increase the amount of times that I get interest, but decrease the interest rate? So over 1 year, instead of doing 1% over 1 year, they might do 0.5%, but then do it twice as much. So they cut the rate in half, but then they do it twice as much. So this is called compounding semi-annually because you're doing it every half year. Now, it is over 2 years, but you're doing 2 times the 2 years, so it's 4 times. Now, the money that you get is $5,175. So they get a whopping 25 cents more by compounding twice as often. So this may not seem like very much, but when you have 1 million customers, take 25 cents times 1 million, it actually amounts to something. So they actually might do something instead like monthly, which means that within this year here, they're going to do 1 plus, they're going to take the 0.01, divide it into 12, and then do it 12 times more often. So again, in the next year, they're going to have 1 plus 0.01 all over 12. And so I'm writing out the expression we would do. It would be 1 plus 0.01, 12. It's really 2 years, but you have to times it by 12 because it's 12 times as often. And sorry, this should be 5,000 right here. Now, the answer here is $5,000, 196 cents. Okay, so as you compound more and more, the bank is getting a little bit extra squeezed out. So here is the actual formula. If you're following what I was saying, you have a principal amount. you're always going to do 1 plus because it's growth. You're going to take the rate and then divide by the number of compounds, k. But because you're dividing the rate by k, you're actually doing it k times as often. So this is the quick formula to figure out compound interest. So let's say that you're doing $100. You have a 4% interest rate over 5 years. There's a couple ways you could do this. We're going to figure it out for monthly, and then we'll figure it out daily. Now, just for your information, student loans are actually calculated daily. So when you look at your student loans, your bank will actually use this formula, but they're going to be doing it daily. So K is 365. So back here, monthly, you have 100 here. 1 plus, the rate is 0.04. Monthly is 12. 12 times 5 years. Now please be really careful when you put this in your calculator. There are so many students that have the right setup, but when it comes time to put this in your calculator, that's what they mess up. Alright, so this is $122, and if I'm rounding correctly, it would be 10 cents. It was 0.0996. Alright, so let's see what daily will do for the bank. It's 365 because now we're doing it 365 times a year. Okay, I actually get 122 still, but I get 14 cents. I get an extra 4 cents by doing it daily. So you may be wondering, well, what if you do it like minutely or secondly? Now there is kind of a diminishing return here. Eventually you're just not making any more money. The jump from yearly to semi-annually was about 25 cents in our last example. And then from semi-annually to monthly gave them another 40 cents or so. But as you start getting down to monthly, to weekly, to daily, to hourly, there isn't actually much of a return. So a lot of banks will just stick to daily.